Hello, I'm Liao. Welcome back to the Build Your Own Svelte series. If this is the first video you're watching about Build Your Own Svelte, well, links on the corner, go watch that. Right? In this video series, we are building our own Svelte, or rather a mini Svelte. In each video, we try to talk about different aspects of the Svelte compiler or the framework compiler, whatever it is. It's that thing that compiles your Svelte code into optimized JavaScript. We have gone through a high-level overview of how a Svelte compiler works, or rather a generic compiler works, and we've polished it up in the previous video. In this video, we're going to add one more feature to our mini Svelte, which is the reactive declarations or statements. The one with a $sign that makes that statement powerful and magical, automatically run by itself whenever something changes. Well, if you use Svelte, you should know about that reactive the magical $signs, right? So how does that work? How do we make that work? Well, we're gonna figure this out together. If you've read my articles, ding ding, link again on the corner about compile Svelte in your head, you probably have seen how reactive declarations is compiled into JavaScript in Svelte. Right? You compare, make changes, and you realize that it sorted the statements, and then whenever you make some changes, it will check if a certain condition, a certain variable has changed, then you rerun a certain statement. Right? So today we are going to have that and implement that out into JavaScript code. So this is more of a compile Svelte in JavaScript. Okay, so let's take a look at our code. So the code over here is what we have done over the past two videos. If you want to read this code, you can always visit GitHub to get the source code. And these changes that we're going to add later on will be on GitHub as well. So now, how do we add these reactive declarations? First of all, let's take a look at the Svelte component. Here I want to declare a few declarations. One is double equals to counter times 2, and a quadruple equals to double times 2. Well, you see that I'm purposefully adding quadruple before double because in Svelte this works. Svelte will reorder based on the dependency between the reactive declarations, so that it will so that the quadruple will always be 2 times of double and double will always be 2 times of counter, right? So you run this to update double and then run the one above to update the quadruple. Here I want to use the two of them in the expression. So I'm going to say counter times 2 equals double, and double times 2 equals to quadruple. Okay, let's save this and let's try and build. Node index.js and build. So this is our compile code. Okay, let's see whether it works. So let me open another terminal. Immediately you see that it does not work. Looking at console, it says double is not defined and it throws error. Well, it works in Svelte, but it does not work at all. Why? Because we have not declared the variable double and quadruple. Right? In Svelte, this is injected automatically, but right now, just to make it work, let me just define these two first and save it. Then let's run this code again. Okay, and let's see. Refresh, and it works. Kinda, right? I mean, this works, but this is still not correct because the order you execute the quadruple first and then double is still undefined, times 0 times 2 is not a number, right? And the increment, decrement does not update. So we need to figure out how we can update this. So first thing is we need to take this out and run them separately, because if you look at the output over here, we have all the code that we write for our component over here, and then we have this reactive declarations or statements over here. Hold on, let me remove this too to make it more realistic, right? This is what you would write over here. This code, if it's just like this as a statement, then only run once, right? We want you only run once, and then whenever we update counter or something like that, it does not update. So what we can do is we can move these variables into maybe like a function, so that we can keep calling and updating it, right? Say for example, if I have, say, let quadruple and double over here, and then have a function called update reactive declaration. Then every time when we update, we also remember to call this update function, right? Then we can technically increment and decrement and update this quadruple and double every time, right? So for example, let me so this is the compile code. Right now we are like compile Svelte in your head thing, where we try to figure out what's the output code that will make things work, right? So here I would say maybe in our over here I would call this update reactive declaration as well whenever we update the counter. And then here we will have to reorder this, and then after updates this, we also would need to say lifecycle updates double. This one, lifecycle updates quadruple, like this. And then yeah, and then we I think that would work. Let's try run our code and see how it goes. So by default we have to run this once, so let's run this once. Let's lifecycle hold on. Okay, so I think there's more things to need to careful about. If lifecycle, right, because lifecycle is declared over here. If we try to use it, then we will have errors. So let's make do with it first. Let's keep it like this. Let's try refresh. Hold on. Okay. Let's define lifecycle first. Lifecycle. Maybe something like this would work. Let's see. Lifecycle. Hold on. Oh, hold on. This have to come after. And now it works. Okay. So there's two things. One is we have to call this once, and then we also have to make sure that when we call lifecycle, this variable is defined so that we can use it. Actually, I'm thinking whether we can do like this type of undefined. And probably we can run this like this. No, I think const is special. You have to, it's already in the scope, but then you can't really access it. So so I would change it into var, and then that works, right? Because the var does not have a temporal dead zone where where if it's declared within the scope, although you haven't the whole scope will the whole block will have access to this variable, but before you actually declare it at this point of time, in terms of this is a temporal dead zone, in terms of time, you can't really access it. This variable, you will throw error. So I guess turning it into var helps in some sense, but we'll look at this later on. Okay, let's just focus on the output right now. So we call first, number one is we call this thing at the start, and then number two is we also call it whenever we make changes to counter. Okay, and then over here in reactive declarations, we kind of order it a bit. So this is reordering, and of course we need to remember to call lifecycle.update as well as number 4. Right, 4 things we need to do to make this works. And does it work? Well, refresh, it looks good. And if I increment and decrement, oh no, it does not work. It failed miserably. What happened? Let me see. Lifecycle updates. Double. Okay, and then over here. Okay, over here we did not include because we didn't look at we didn't think that this double and quadruple is a variable that can change. Double and quadruple is a variable that we can change. That's why we did not add the code to updates the variable. I think if I do this, let me think, quadruple and double. If I do this and try to compile this code, but in the meantime, let me keep some of the code here first. No, it does not work that way. It doesn't really look into why does not work? Let's see, double, quadruple, double. I mean, we update this obviously, but why? Okay, so let's look at our analysis code. In our analyze, what will change, we'll use and variables. Let's see what are they. Let's see, console log result. What do we have? Variables. Will change is just counter. And then okay. Why is that so? I thought we handled. Wait, let me see. What did we not handle? We handled updates, expressions. Okay. We mentioned that we will handle the assignments as well, but we didn't really do it in the last video. Do you do your homework? Well, that's why we did not. So let me add that in. Assignment expressions. Find own. Okay, and then we need to hold on a minute. This is not the changes we had last week. Let me roll that back. Okay, obviously I've rolled back my code. Yeah, I probably on a stale branch. I didn't check before I start recording. But anyway, let's see what do we have over here. Right, my code now has analysis. When do we do analysis? Analyze. We do handle updates and assignment expressions. So this will constitute as updating the variable as well. And if we take a look over here, indeed let's see, we have this and we have this as well, right? Because this is also wants to update. And then if we take a look later on over here, as we do the update lifecycle, all of this is listens to the change when we do changes. Okay, so here, let's see. I'm gonna paste back some of the code that I copied earlier on, right? This is what we say 1 and 2 that we need to do. And then here, here we will change a little bit from what we had. This thing, maybe we have to check for life cycle for now. Just take a look for now. We will change that. So if we have this code like this, then come to the browser and refresh, then this reactive declaration would work. Yay! Okay. The thing is that you need to know when you do here we do lifecycle update, and we kind of know that okay, maybe we are looking for we are updating counter, and counter will affect our reactive declaration. We need to add this in. But would it be easier if you have like a generic function that does the updates, right? For example, you make something dirty, and then you keep track of that, and you clear that. You keep track of that, and then in the lifecycle updates, you instead of calling lifecycle updates, you call update reactive declarations instead, or calling some update cycle instead, right? I'm not sure where to get me over here. I obviously don't understand what I'm saying as well. Sorry. Well, it's better to look at code than to listen, right? I guess that makes you that gives a clearer picture. Well, how about let's take a look at the code instead. Hopefully that paints a clearer picture. So I was saying that maybe we have a function like life cycle, like an update cycle, and over here when we call up, and then we also have a variable called dirty. So here in our update, over here we, instead of calling lifecycle.updates immediately, and call this function immediately, maybe it's easier if we collect all of this. We call updates. Hold on. Let's dish this. Dirty, right? I think here we call change. Okay, change. Let's keep the variable name consistent, right? Change. We, instead of calling lifecycle update directly, we call updates, right? Everywhere we call updates, like this. Updates counter and updates this. And here, same thing, updates. Updates. Okay. So in the update, we also need to call updates reactive declarations. And then we need to remember to call lifecycle with the lifecycle dot update with the change. Okay, here we are calling this again, which will cause like some recursive. Let's see how we can solve that in our mini Svelte. So let me think. Okay, so here if we have a variable, we move the change out, right? Like a collect changes over here out like this. Then every time when we call updates, we will gonna push all of them in change for each. Like this. And also we need a flag. So let's will update, or no, update call equals to false. So every time once we come in, we'll say update call equals to true. So if we check update call, then return, right? So over here, what we've done is that you can keep calling updates over here or over here. You can call multiple times in the same place. It's okay. But you will not do, it will only continue forward after for the first time, and subsequently it will block because it has been called, right? So here, if it's the first time, here is what you will do in the first call. You will call live update reactive declarations, and then call the lifecycle update with the collect changes over here like this. And then when you end, you will say update call equals to false and collect changes equals to an empty array. Alright, so first time you call, you will, it's false, so you know how many, every time you call, you will call this collect changes, and then here you make sure that you only call once to hit the rest, and in the rest you will call once for update all the reactive declarations as well as update the lifecycle. And then when that happens, when you successfully updates everything, then you reset it back by setting this to false, setting this to empty, right? So this is our update mechanism, right? So here onwards, we stopped calling lifecycle updates directly. We just call the update function. Then update reactive declarations over here. We can, of course, call here. We need to first call once and also have all the reactive declarations over here. Okay, so the name for this function needs to be unique. Actually, I mean, we have been quite lenient about, just call lifecycle. If you have your code here declared a variable called lifecycle equals to something, then it will definitely have syntax error because you declared lifecycle twice within the same scope, right? Because you would definitely have your code have a let lifecycle over here, and then this will conflict with the lifecycle. For now, we just keep it as it is first, and then later on we see how we can deconflict by renaming this variable. Okay, so first of all, let's just call updates. Okay, and this is the updates reactive declarations. So you can't have updates in your you can't define a variable called updates over here at all. Okay, so this one is quite standard. There's nothing over here being depended by the lifecycle updates. Sorry, there's nothing over here being depends on the code you write, as long as I think even without reactive declarations or not, you can still define this function over here, make it an empty function. Or maybe you think you want to hide this line if there's no if there's no reactive declarations, right? So it's up to you how you can define and optimize your code. Here I'm gonna leave it on for now, and then you can figure out how you can hide this line, or maybe the entire updates, and fall back to call lifecycle.updates when you don't have any reactive declarations, right? It's up to you how you can optimize this, right? So now for now, we're gonna just render this, we just keep this whole thing in. So to do that in our code, this is where we have our output code looks like, right? In the generate function. So after we declared all the variables, we can also put in this piece of code over here like this, right? Collect changes, update calls. I think these variables really, you can't really have your variable name like this, or else it will conflict with the scope. So it's something we need to definitely figure it out. Let's see, update calls, update reactive, and then here we also have our reactive declarations. We have this once, and then we have this function like this. Okay, and I think here we also need to check. We change this to var, right? Make things easier. And over here we check if type of life cycle equals to undefined, not equals to undefined, then we will call lifecycle.update. Here, let's see. Here we will need to insert code dot reactive declarations dot join, meaning the code itself will have another array called reactive declarations. Let me come over here and make it an array. Okay, let's see. What else is there? I think that's it. We are done. Okay, I think that's nice. Let's remove this too. Now the next thing is we have all the outputs over here. Okay, this we need to change to our update instead of lifecycle.update. So let's see, lifecycle. Here we change it to update instead. Okay, I mean, with this done, next thing we need to do is basically extract out the reactive declaration so that it's not part of the instance script anymore, right? It's not part of this script over here. So before that, let's try to run and take a look at the output. Let's see. This one. So this is the output code that we have. We have this. This code is still here. We need to change that. Here we have update. Oops, sorry. We have over here, everything is generated already. Now the next thing is extract these two out into reactive declarations. So to do that, first thing is we can do it in our analysis. Let's go up, and here, this is where we do our analysis, right? Analysis AST. So here in our AST script, we need to, I think, let's take a look at our result, console.log result. I want to show you something, right? So here in the result, will change is just, we only will change counter. Why? Because we did not define increment and decrement. We did not define quadruple and double. So it's not defined or declared in the root scope, and then it's not considered as something will change because the owner is in the root scope. So I think we need to add one more change, is that it's either this or the name is in the global scope here when we do globals. Because here we have this variable quadruple, but it's not defined or declared anywhere in this script, so it's assumed as a global variable. So if it's also a global variable, then we kind of know this is a declarative or reactive declarations. Then I think like this, find owner. The name, globals that has name. Then we can treat it as something that will change. Okay. Then with that, I think our code, we also do the updates already, right? Fair enough. It makes sense. So you may be asking, is this the most correct way? Because what if you are changing maybe say console or something that is like a global API in your JavaScript, right? Like the this or console or whatever, right? I mean, you are right. So this is temporary. I think a better way is to before we go through the script, we analyze, extract out the reactive declarations, and we add those things into the root scope as well, or rather like in a map or somewhere. Okay, so let's see here. The reactive declarations is always in the body, right? If you have a function like looks like this, function, and then you have this this dollar syntax inside, then this is not reactive declarations. We don't really care. It has no effect besides the top level, which is here. So in ST, when you have it here, it's directly in the body. So we can actually look dot body dot for each node. If node dot type equals to label statement, let's console out, right? So here, let's see. Then hold on, I think the name is wrong. Let me find how it's called label. Okay, with a 1L. And see that here you have the statement, right? And then the body is this expressions itself, and then the label is just the label, right? So if it's label statement and the node dot label dot name equals to the dollar sign, then we know it's our reactive declarations. Okay, now so here we need to extract something out of it. We need to know a few things over here, right? We need to extract this whole reactive declarations out, and we need to analyze a few things. Right? First is, of course, we need to store it in an array, reactive declarations as an array. And then now, so we look at the left and right side of the statement, right? Of your declarations, right? The left side and the right side. Because left is what you will change, and right is what you will depend on. It's like a dependency of this this statement, right? Whenever the right side, any variables on the right side changes, then you have to run this statement, right? And this, the things that on the left side is you need to declare them and at the top, right? Because this variable is not declared yet, so we need to look at the left side and the right side and do different things on different sides, right? So here we have a label statement, and then the statement that we're looking at is like the body, right? The body, node dot body. And if you look at the expression itself, that's assuming it's an expression statement. Then the left and the right is looking at the operator, right? You're looking at the operator, left and sorry, let me see, expression statement. So the body is an expression statement. I think we can just assume it is an expression statement. So then if the body dot expression dot left, okay, no, this is the left side and this is the right side. Okay, technically you should use ES3 walker to walk the script, and then when you found assignment expressions, then you should do something about it, right? And you also need to handle update expressions. But in our case, we just assume it's always an expression statement, right? So things could go wrong if we have things like multiple statements over here. Then it's no longer an expression statement, right? Things could go wrong if you are doing something like foo a b, right? Then this is the dependent. This is the there's no assignment over here. You depend on foo a b and then you do something. Okay. For now, we just assume that this is always an assignment expressions, and I mean it's the same thing. The thing that you need to do is almost the same, right? So here in reactive declarations, we need to push a reactive declarations here, but it will be something like we restart what will change assignee and dependence, what it's depending on, and then maybe the node itself, right? So that we can insert this node later on. So the node is the let's see, the node the body node, which is the body. Okay. So here, assignees, we can safely assume that this is just an identifier, a variable. So this is the left dot name. At the same time, you also should need to know that we will also need to say this is something that will change, right? Left dot name dot will change, result dot will change dot add left name. Dependents are on the right side. Okay, right now we can use ES3 walker to walk the right side of the tree, and then whenever we enter and whenever we encounter node dot type equals to identifier, then we say that it is your dependence, right? So here dependence goes an array. Here we say dependence push node dot name, and dependence, put it here. Okay, this could go wrong a lot of ways as well. For example, if you have something like double dot foo, then this whole thing itself is a member expressions, but then this and this are both identifier, right? I think it makes more sense if you look at over here in this AST Explorer, right? Double dot foo, then you have let me drag it. This whole thing is a member expression, but you have left and right object is an identifier. The property as well is an identifier, okay? So we made a lot of assumptions over here just to show you the mechanics, but you have to write, you have to do the dirty work to actually traverse through a tree and figure out what is needed, what is not needed, and then handle individually. But anyway, we have this reactive declarations. Then what we can do is we can push it to reactive declarations dot push reactive declaration. Okay. At the same time, we would want to extract this out from the script itself, so that we don't have to analyze them later on. we don't really care anymore because we already know what will change and what are the dependencies. I think we should call it dependencies. We know what is the dependencies, what is the assignees, what will change, and then the statement itself is over here, the body we have extracted out. So I think we should remove it, right? So a good way to remove it would be figuring out, I think would be not using a for each, because you have to remove while doing for each. That it's a bit wrong. I think what we can do is that, let's see, node equals body. I think one thing we also need to do is we have to keep track we should keep track the index as well over here. Yeah, maybe we need to order, and then index will be something useful when we do reordering. But anyway, after we gone through everything, I think what we can do here is that we can have let me just quickly do this. We can have a set of the reactive declarations. The node itself. So this we map to the node. Right, and then the script, the body itself, we can filter. We can assign by filtering filter statement. Hold on, node. No, it's not correct. I mean, the node is the body, right? Hold on. Let's see. Okay, let me just do like do remove equals to new set. Over here, once we decided, then we're gonna remove dot add this node. Okay, and then here we filter by say not to remove has the statement, or rather it's more of like a node. It does not have to be a statement. It can be I think it's usually a statement. Anyway, here we filter it out, and then let's try run this code again. At this point of time, if you look at the output code, you find that there's no more $sign because it's gone. We removed it, and we haven't added them back in over here. Update reactive declarations. Okay, so to add them back, we can come over here. First is we need to add this into somewhere, right? This will be part of our analysis result. So result dot this is this thing over here. Okay, now so that you can use it in our generate code. So when we generate the code, we can here after we handle things. Hold on, handle this. Okay, so here in our analysis dot reactive declaration, for each reactive declaration, is it declaration or declarations? Declarations, right? It's a plural. Reactive declaration. What we have over here, we have the node, we have the index, we have the assignees, we have the dependencies. Okay, here the code dot reactive declarations dot push. Here, what do we push? Well, depends on the dependencies, right? If something in the dependencies has changed, then we need to run our node itself, right? So here I would say if change here update reactive declarations, and we will include the change, right? We need to call the change. We need to pass the change in here. Hold on, let me pass it in. Change. This is empty. This is change. here, if change includes, right? I think you are familiar with this part. If change includes, and then we have like this, this thing, right? The stringify from thing. Let's copy this in. If this thing has some of the changes here, okay, then we need to do our node, right? We need to execute this, which is we can use the ES code gen to generate it out as JavaScript. The node, okay, and then we also need to add new changes, right, to it. So it's like change dot no, I think it's called updates, and then we call updates on the assignees. Okay, updates assignees, which is we can say json.stringify assignees. Okay, let's save this, and I think we are great. We are good. So here, hold on, changes, stringify array from changes. No, this is dependencies. Okay, here let's take a look at our output code. Here we have added 2 lines. One is the count double. Then we will, if double have this, then we will do the quadruple equals doubles times 2. And here, if we have counter changes, then we will do this, and then we update the double. Okay, and we also define, no, we have not defined the variables. We have not defined the double and quadruple in the variables because variables are based on, let's see, variables. Yeah, we should add new variables in as well. So variables, code.variables.push assignees, or rather like assignees for each assignee. Okay, we add each assignees into the list of variables so that it will generate it over here. Run this again, and you'll see that now we also have double and quadruple, so that it's declared, right? So that it's declared, and then you wouldn't run into undeclared variables. So if you try to run this code again, it's kind of work, kind of not work. The double works now, the quadruple does not, because the quadruple depends on double, but you only run this one statement once every time. Then you only run it once, then I would say, like, in that case, then sorry, what was I saying? In that case, then this thing will never run because double has never changed. Double only changed over here. So yeah, you never got to run it. And one thing you realize is that if I refresh the first time, it's undefined for all, because here I'm passing empty array and nothing has changed, right? So the first time we're running, we want to have a state where it says everything has changed, right? So we need to find a way to signal that, to say that everything has changed, right? One way to make it different is that maybe we can pass in undefined or not passing anything. Then if no change, nothing, then this is kind of against your natural instinct. But I mean, if we want to use undefined as a way to signal it, then we can use this, right? If nothing, then we do everything. Or if you know all the variables, you put everything in here like counter and like double and like quadruple over in here, that would work as well, right? So what do you think? Yeah, what do you think? I don't really know. So first I am just gonna write this first because it makes more sense naturally, but it's more code, but we can optimize in terms of the code. To do that, basically we need to know all the variables that will change, and we add those and we add them in, right? So that is more straightforward. We know what will change, right? Because it's in the analysis dot will change. Let's stringify this, and let's try and run this again. Okay, here is our code. Hold on. It's a set. So let's turn it into an array first. Let's try run again. Right here, these are all the things that will change. So as we run, let's run on the browser. The first go, everything is now correct because the first time we call this, we kind of assume that everything has changed. So you will run all the reactive declarations, and then so that your quadruple is now 2 times our double, your double is 2 times the counter, and everything is correct. You see it's correct. But it's not really correct because if the counter starts with 5, and if you run this code, you hold on, 5 times 10. Hey, it is correct. It is correct because counter. Let's trace this because if call this we call this and then we'll call updates, and we kind of thought that updates is the first time we call. That's why that's why we kind of call this update reactive declarations again. But if you change this to updates, we call update reactive declarations again, and we go updates, and then we call this one more time, right? So twice. That's why we managed to go this thing twice and updates this quadruple, right? The first go, double has changed. Double has changed, but double is undefined, so quadruple is not a number. And then you go through here, and then double equals to counter times 2, you get the correct like 10. And then you have these 2 updates, which triggers another round of update reactive declarations. So the second round, when it goes through this again, quadruple is now 2 times of double, which is 20, which is update. And then this one is still 2 times, but it's the same value, so nothing changes. And then if you render that, right, this everything has changes, then you call the lifecycle update. Well, we don't really update because we don't have the lifecycle yet. But then when you create the element and we want to create the value over here, it's with the correct value. But this has side effects. It runs twice, right? So if I console log here, you realize that it calls multiple times. So one way you could do is, instead of calling update reactive declarations, you can call updates instead. So they make sure that we call updates will make sure that we only call the update reactive declarations once right before we call the lifecycle.updates. Okay, so if I refresh this, you see that there's only one question mark printed, and this is not a number. Okay, so this is a more correct behavior. So let's update this. This is update. Now, one thing we have not solved yet, which is to reorder these statements over here. Okay, so for that, we will have to figure out we will have to do a sorting, right? Before we do this part, we have to do the sorting. To sort it out, we will use the sort, because it's an array, we can run sort. But how do you compare two different reactive declarations? So I'm calling it RD1 and RD2. Reactive declaration 1, reactive declaration 2. How do you compare? Right? So first is that if RD1 if RD1 is having is changing, right? For example, RD1 is changing assignees, and if like RD2's dependencies, right, it depends on has whatever RD1 is changing, right? So it's like RD2 depends on what RD1 changes. Let's see. If this, something like this, then RD2 should come after RD1. So, and the other way around, if the other way around, where RD1 depends on what RD2 changes, then RD1 should come after RD2, right? Depends on what it changed, right? And it does not depend on each other. It does not change whatever each other is changing. Then we would say that we just order based on its original order. So based on original order. So here, let me change this. RD2, so let's fill this up, right? So first of all, this is an array. This is an array. So a correct way of writing this should be this one, sum of this assignee, where this one has, right? So, and here is the same thing, RD2, sum of the assignee. Is this. Okay, so how do we say this should comes after, right? If you do normal sorting, right? If you do normal sorting, like for example, 1, 2, 3, dot sort, A, B, the default behavior of this normal order sorting, numerical sorting, is A minus B, right? And what that means is that it returns if A is bigger than B, then A minus B is greater than 1, right? And the other way around, where B greater than A, then A minus B is -1, right? So meaning if this is 1, then A is greater than B, right? So it's like the left side has to be, the A has to go after B, right? So when A goes after B, you say 1, right? So in here, RD1 comes after RD2, then we return 1. And if it's the other way around, where the second word should come after A, then this returns -1. Okay, and lastly, we have over here, we are just based on the index, so index minus RD2.index. So whoever comes first in the index order then comes first later on, right? So if I try to run this again, let's see, dependency has dependencies. Let's see what's wrong with this. Is it the name? Dependencies, reactive declaration, dependencies, assignees, dependencies. Oh, not has. I think it's called includes. If it's an array, includes. Okay, then nothing wrong, right? We managed to run it perfectly fine. let's take a look at the generated code. Now you see that it is reordered, right? So here it depends on the counter first and then the quadruple. If I try to refresh this, now it's correct. Every time we increment, this is still not correct, right? Why? Oh, okay. So here updates double, updates the change variable, but then here when we check the change, this array is still the same one, or rather this array is the one that is being passed in that is not updated yet. I think we should just call this with this one, right? The one that has everything. Then we can make sure that then we can, okay, I think just we don't have to, since we already have it globally, I think we don't really need this change. We have it over here like this. Then every time we update, when you call update this variable, right, immediately. And then so here it reflects, right? So here let's change that a bit. Here we don't pass it in, and here we don't do this. And then here in the code we say this one. Okay, let's try run again. And let's take a look. Okay, seems like it's working now, right? Every time when we change, we update the variable, the double, and then the double updates the quadruple. Yay! So let's make a few changes and see how it behaves, right? So if I maybe have another variable, let's say counter, say foo equals to 5. And if we have, say, bar equals to foo plus 5, save this, let's run this, and let's take a look at our code. So this and this two does not depend on each other, so it doesn't really, it keeps its order. This comes first, and then this two comes later on. But if I reorder this, if I count it, edit last, if I try and run this, then you'll see that this will come after of this two. Although it doesn't really matter because this and this two doesn't really affect each other, right? One thing we can add also, like say for example, this depends on double, then immediately you can see that, sorry, I think we should change this to plus foo or plus bar, save this. Then immediately you can see that now this reorders and goes up, and then this comes here, and this doubles is here. So so there's reordering, right? Because this will update this bar, and then this will depends on whether the bar or counter has changed. So if I let's see, I think let's add foo over here. And let's add a button to update foo as well. Okay, so now foo is this, and every time when you increment, it will update the foo as well as updates the bar, and then bar will update the double. Okay, so I guess that's it for reactive declarations. We've kind of handled most of the cases. Of course, we do have some of our assumptions when we implement this. We assume that this is always one variable, and then this are like normal assignments. This whole statement is an assignment, but the idea itself is the same. We have to figure out, we have to collect what is the what is the assignee, you will change, and what is the dependencies, basically what it depends on, and then we reorder them. And then of course, to make this thing works, we kind of extract it out as we have a separate updates function that will, wherever you updates, you will call this function, and so that you will call the lifecycle updates to once instead of multiple times, and you will call the reactive declarations and lifecycle update once after all the changes have been made, right? So that's all for this video. And next one, we are looking at probably some refactoring of our code, so that once after that, you probably will have a clear idea of how we actually structure our code in actual Svelte code base. So see you in the next one. Bye bye.